Hey everyone, today we're looking at notes 1-4, inverses. So before we begin, I want to remind you that your name should be in the upper right hand corner in pen. So let's get started. So inverses have x and y values that are switched. Therefore, they have domains and ranges that are switched, because if domain is composed of x and range is composed of y, and you take those values and you switch them, then of course the domain and range will be switched as well. Okay, inverses when graphed are symmetric about the line y equals x. Okay, inverses are not always functions. Inverses use the notation y with a superscript of -1 for non-functions and f with a superscript of -1 of x for functions. Okay, and this is read inverse equation. You don't say y to the -1 power, you say inverse equation. And for this, you say inverse function. You don't say f to the -1 power of x. You say inverse function. Okay, so one-to-one functions. That's a new definition for you. So one-to-one functions are functions in which each y value corresponds to exactly one x value. So in other words, there are no repeated x or y values. Okay, one-to-one functions pass both the vertical and the horizontal line test. One-to-one functions have an inverse that is also a function, and that makes sense because if inverses have x and y values that are switched, and if the y values don't repeat, then when you switch it, that means the x values won't repeat, so you will have a function. Okay, so let's move on to some examples so we can really cement this knowledge, okay? So first, graph the function. Okay, so on number 1, we're given this function that's just 3 ordered pairs. That makes it easy. Let's graph it like it says. So 2, 3, that's our first ordered pair, -1, 4, and 0, 3. Okay, so we've graphed said function. Then we need to determine if the given function is one-to-one. Well, we have 2 ways we can do this. Remember, we can check both the vertical and the horizontal line test, and you can clearly already see this is not going to be a one-to-one function because we're not passing the horizontal line test here. We're hitting 2 points at one time. So we can definitely use the vertical and horizontal line test, but you could also just look at the x and y values and see if anything repeats. So in x, nothing repeats, but as we already knew, because this graph didn't pass the horizontal line test, the y values here repeat. So that means we don't have a one-to-one function. So it's not one-to-one. So what does that mean? That means if we're not one-to-one, then the inverse will not be a function, because if it was one-to-one, then we would have an inverse that's a function. So let's see. Okay, so determine if the function is one-to-one. We did that. Now let's state the inverse. So we claimed that because this is not one-to-one, the inverse will not be a function. So that means I can't use this notation because that notation means inverse function. I just want to simply use inverse equation since it's going to be a non-function. So I'll say, when I'm stating the inverse, I'll say inverse equation equals, and then I will use the braces and I will switch, like I've been told, I will switch each x and y. So this will become 2, 3 will become 3, 2. Okay, -1, 4 will become 4, -1. Did I say -4? I meant 4, -1. If I said it wrong, I'm sorry. Okay, and then 0, 3 will become 3, 0. Okay, so there's my inverse equation, not function. So now let's go ahead and graph like it tells us to do. So 3, 2, 4, -1, and 3, 0. And it makes perfect sense, just like we assumed, just like we wrote here, inverse equation, not inverse function. This pink graph here does not pass the vertical line test. Therefore, we don't have a function. And that makes sense. That's what we thought, okay? So then we're going to state the domain and range of the function in the inverse. Okay, so let's do that next. So the domain of the function, right? Remember, domain means x, so that's going to be 2, -1, and 0. But remember, I have to put it in least to greatest order, so -1, 0, 2, and don't write repeats. Okay, so there's my domain, here's my range. My range is the y values, so that's 3 and 4, and I don't list repeats, and it is in least to greatest order. Okay, so I've got my domain and range of my function, but now let's do the domain and range of my inverse. So for my inverse, the domain, looking at my x values, they're 3 and 4. So I'm going to write 3 and 4. And then for the range, I've got 2, -1, and 0. And again, I need to do -1, 0, and 2 and make sure my values are in least to greatest order. And then I'm just going to check, just to check myself, did it do what I expected it to do? Did my domain and range switch? Yeah, domain became the range and range became the domain, just as I expected. So that's good. We're checking ourselves to make sure we're good. So now I've done that part. So then it says draw the line of symmetry as a dotted line. Okay, so the line of symmetry is the line y equals x. So I'm going to go ahead and draw in these dots here for the line y equals x. Remember, that's the y-intercept is 0 and my slope is 1, so I just go up 1, right 1, up 1, right 1, forever as far as I can go. And then I'm going to use my straight edge here, and I'm really going to do more of a dashed line than a dotted line. I mean, it is dotted, but it's kind of dashed. Okay, and there's my arrows on both ends. And what's really cool is, just like it said above, we are symmetric about this line y equals x, the line of symmetry. So if I were to simply fold over that line, I hope you would agree with me that these 2 points would lie on top of each other. These 2 points would lie on top of each other. And furthermore, these 2 points would lie on top of each other. So that's just another way to check your work. All right, so let's go ahead and move on to number 2. So on number 2 for this function, what did it say to do first? So graph first. So we'll do that first. So -2, 1, 2, 3, 4, -1, 0, and 1, 3. So after we graph, it said determine if the given function is 1 to 1. So again, you can use the vertical line test and the horizontal line test, and it looks like it passed. So I'm going to say 1 to 1, but I'm going to double check myself by just making sure that no x values repeat, that's correct, and no y values repeat. So yes, it is true, it is 1 to 1. That means, so once I've determined if it's 1 to 1, then I can state the inverse. That means my inverse will be a, you guessed it, a function. So now we can say inverse function equals. Okay, and what will my inverse function equal? Well, switch all the x and y's. So -2, 4 will become 4, -2. -1, 0 will become 0, -1. And then lastly, 1, 3 will become 3, 1. Okay, so then I've stated the inverse. Then I'm going to graph the inverse like it says. 4, -2. So 1, 2, 3, 4, -2. 0, -1. 3, 1. 1, 2, 3, 1. And if I'm only looking at the pink points, is it as I expected and this passes the vertical line test? It sure does, so that's definitely right. It is a function. So then I'm going to do my domain and range. So domain and range. So my domain here is going to be -2, -1, 1. -2, -1, 1. My range here is going to be 0, 3, and 4. Okay, and then let's go over here and do this guy. So my domain here is going to be 0, 3, and 4. And then my range is going to be -2, -1, 1. And then I'm going to check. So are these switched? They sure are, so then we're good to go. Okay, lastly, we need to draw that line of symmetry, the line y equals x. And just really quadruple check ourselves. But it does seem like everything is adding up just like we suspected. So here's our dashed line. Okay, and those points would fold on top of each other, those points would fold on top of each other, and finally those points would fold on top of each other. So we've done a great job of finding that inverse. Okay, so that was graphically. Okay, so graphically, you take each point, you switch it, and that's your inverse. Okay, what if I have something where I say find the inverse equation and I don't provide a graph? Now, I could, if I provided a graph, I could plot this line, and I want you to listen to this because you're going to have to do this on your assignment, and I'm going to really know if you listened to me today. what you're going to have to do on your assignment is there is a section where there's a graph here. You're given an equation like this, like a linear equation, so you'll plot the line. Once you plot the line, you'll pick out 3 points, okay? And you'll pick out those 3 points and you'll switch the x's and y's. You'll plot those new points and then you'll draw a line through those points. So you can do that for sure. But here, when I'm not provided a graph, then I must assume that I'm being asked to find the inverse equation algebraically. So how do we do that? That's a great question. It's actually not so bad. Your first step is to rewrite f of x as y. So we've got this function, and remember that x needs to stay in the numerator. Okay, we've got this function, and we're going to rewrite, that's our first step, rewrite f of x as y. Okay, and you'll see why in a minute, because we want to switch x and y. So that's actually our next step, is to switch x and y. Okay, so once I rewrite f of x as y, then I switch x and y. And so this becomes x equals -4/3 y, plus 4. So y plus 4. So I switched where I saw x and where I saw y. I made yx and I made xy. Okay, and then I'm going to solve for the new y. So get the new y all by itself. So that means I'm going to move this plus 4 over to the other side. So of course, when that moves over to the other side, it's going to become -4. Then I've got -4/3 y. And again, I still want to isolate y. So I'm going to multiply both sides. Here's where you have to be really careful. Both sides by the reciprocal. Not the opposite reciprocal, but the reciprocal. So just switch it. Don't flip the sign. You keep the sign. Okay, so what I do to one side, I must do to the other. And here on this side, the reason why we keep the sign is because if you just made it a positive, then this would still be a negative y. But here, when I have a negative times a negative, that turns into a positive y. And of course, the 4's simplify out and the 3's simplify out. So I've got a positive y here. And now I need to be very cautious and make sure I distribute. So this becomes -3/4 x. And then what's -3/4 times -4? Come off to the side if you need to. -3/4 times -4/1 or -4. Come off to the side. See that those 4's simplify, and you've got another negative times a negative situation, so that becomes a +3. And then you're pretty much almost done. Your last step is to replace y with that inverse equation notation or the inverse function notation, depending on if the inverse is a function or not. So that's something you got to know, okay? So is this a function? Well, hopefully you're going to be shaking your head yes, okay? Because this is a linear equation that's in slope-intercept form, okay? It's y equals mx plus b form. It's a line with a negative slope, and it would pass the vertical line test, okay? So your final answer is going to be the inverse function notation equals -3/4 x plus 3. So that's your final answer.